In this video, we're going to discuss compositions of inverse trig functions on trigonometric functions. For the most part, the inverse trigonometric function will correspond to the trigonometric function. So we are going to see a lot of problems of the following nature. So an inverse trigonometric function of a trigonometric function of an angle. Now, typically what will happen is when you take the trigonometric function of an angle, this is going to give you the corresponding ratio. Then, taking the inverse trigonometric function of a ratio will give you an angle. Now, a great question to ask is, won't the trigonometric function and inverse trigonometric function simply cancel each other out? And the answer is, well, yeah, sometimes, as long as the angle is within the appropriate quadrant restriction. Now, when it came to the appropriate quadrant restriction, we typically label our angles in the following fashion. So from 0, we could rotate in the positive direction as much as pi, and we could rotate in the negative direction as much as negative pi over 2. The inverse sine was restricted to quadrant 1 and quadrant 4. So if you had a quadrant 1 or quadrant 4 angle, that is an angle between negative pi over 2 and positive pi over 2, then yes, these would just cancel each other out. For the inverse cosine, we were looking for angles that are between 0 and pi. So as long as you have a quadrant 1 or quadrant 2 angle, yes, these will simply cancel each other out. For the inverse tangent, as long as the angle was between negative pi over 2 and positive pi over 2, yes, these would simply cancel each other out. Some examples. If I wanted the inverse sine of the sine of, let's do pi over 3. So pi over 3 would be considered a quadrant 1 angle, corresponding to 60 degrees. In a case such as this one, yes, these would simply cancel each other out. Similarly, if I asked for something like the inverse cosine of the cosine of 3 pi over 4. 3 pi over 4 is over here in quadrant 2, and that is part of the restriction for the cosine, so yes, these would simply cancel each other out. Or if I wanted the inverse tangent of the tangent of negative pi over 7, which I realize is not a familiar angle from the unit circle, but that doesn't mean that it doesn't exist. Negative pi over 7 is within quadrant 4, which is part of the restriction for the tangent, so yes, these would simply cancel each other out. Now, a more interesting case is going to be when they don't simply cancel each other out. For example, if I gave you an angle that's in a quadrant that isn't part of one of the restrictions. So if the given angle is not part of the appropriate restriction, chase it to the appropriate quadrant. If the given angle is not part of the appropriate restriction, chase it to the appropriate quadrant. For example, if I ask you for the inverse sine of the sine of 2 pi over 3. This is the problem that I was about to start earlier, and then I realized that I really shouldn't do that. Now, 2 pi over 3 does happen to be a familiar angle from the unit circle. As such, what we could do is simply evaluate the sine of 2 pi over 3, and then take the inverse sine of the corresponding ratio. Now, the ordered pair that's associated with this in quadrant 2 is negative 1/2 and root 3 over 2. So the sine of this angle would be the root 3 over 2. When we ask for the inverse sine of root 3 over 2, though, we're trying to find the angle that is between negative pi over 2 and pi over 2, that has the same sine. That would be this angle in quadrant 1. Specifically, that would be pi over 3. Now, there is a shorter way to do this than to evaluate this. The advantage that we had on this problem is we can actually evaluate the sine of 2 pi over 3. Now, the quicker way to do it is to say, or chase 2 pi over 3 into quadrant 1. Given that 2 pi over 3 is a quadrant 2 angle, the way that we chase it into quadrant 1 is by doing pi minus that angle. That is to say, we were looking for this reference angle. So, pi minus 2 pi over 3 would give us the desired pi over 3 that is our final answer. Now, this is going to be especially handy if we don't actually know what our familiar angle happens to be. For example, if I ask for the inverse sine of the sine of, let's do 13 pi over 9. Now, 13 pi over 9, once again, is not a familiar angle, and we need to figure out in what quadrant this angle would be. Now, hopefully it's very easy to identify that this is bigger than 1 pi. Getting a common denominator would be 9 pi over 9, so it's definitely bigger than pi. But it's also smaller than 2 pi, due to the fact that 2 pi would be 18 pi over 9. Now the big question is it greater than or is it smaller than 3 pi over 2? Now there is a little way that you can test to see which one's bigger. Write down the two fractions, 13 over 9 and 3 over 2. We'll forget about the pi's for the time being. Cross multiply. 2 times 13 is 26 and 9 times 3, 27. Which one's bigger? This one's bigger. At the previous step, the same one will be bigger. So 13 over 9 is less than 3 over 2, which means that our angle is smaller than 3 pi over 2. Not by much, but it is smaller. So we will draw this in quadrant 3. Now again, this isn't a familiar angle from the unit circle, but I do know that because we're in quadrant 3, this will be negative x and negative y. Now with that in mind, we are interested in finding, well actually if it's labeled like this, we'll just go ahead and call this the inverse sine of negative y. Given that we're looking for the inverse sine of a negative ratio, we would be looking for the corresponding quadrant 4 angle. Now, given that it's in quadrant 4, the x value would be positive and the y value would still be negative. We are now looking for this angle. Now, what that means is if I can figure out this reference angle and then simply tag on a negative sign, we'll be all set. Which means that given a quadrant 3 angle, I would want to chase it to quadrant 1 to figure out the corresponding reference angle. The way that we chase from quadrant 3 to quadrant 1 would be to take our angle, 13 pi over 9, and subtract pi. Now subtracting pi is like saying subtract 9 pi over 9, getting a common denominator. And then once we have our common denominator, we subtract. That'll be 4 pi over 9. So this angle up here would be 4 pi over 9, but again, we're not looking for this angle, we're looking for this angle in quadrant 4. So this angle would be the same reference angle, just toss a negative sign in front of it. Your final answer is going to be negative 4 pi over 9. This is the angle that's between negative pi over 2 and positive pi over 2 that has the same sign as 13 pi over 9. Let's try another example. For this one, I'd like to do the inverse cosine of the cosine of 13 pi over 8 this time. Now, first thing we should do is sketch 13 pi over 8 and figure out which quadrant that's in. Definitely bigger than 1 pi, Definitely smaller than 2 pi, because 1 pi would be 8 pi over 8, and 2 pi would be 16 pi over 8. Additionally, if we were to get a common denominator for them, 3 pi over 2 would be the same as 12 pi over 8. 13 pi over 8 is bigger than 12 pi over 8, so this will be a quadrant 4 angle. In quadrant 4, I know that x is positive and y is negative. Now, based on this labeling, that means that I would be looking for the inverse cosine of the x-coordinate. Given that this ratio is positive, I'm going to look for where the cosine is positive. That'll be in quadrant number 1. So this is the angle that I'm trying to find. Now we've already established that this angle is 13 pi over 8. If we can figure out this angle, that should be equal to this angle in magnitude, which means that I want to chase this angle from quadrant 4 into quadrant 1. Chase from quadrant 4 to quadrant 1. The way that we do so is we take 2 pi minus the given angle. That'll give us our reference angle, and our angle will have been chased to quadrant 1. So this will be 16 pi over 8 minus 13 pi over 8 for an angle of 3 pi over 8. That is the angle that we were looking for, so that will be an angle of 3 pi over 8. And since we're doing as well as we're doing, let's try out one more. Let's do the inverse tangent of the tangent of 4 pi over 7. Now for 4 pi over 7, definitely between 0 and 1 pi, due to the fact that 0 would be 0 pi over 7, and pi would be 7 pi over 7, so 4 pi over 7 would be between those two. Checking 4 pi over 7 versus pi over 2, we can do the same thing that we did just a moment ago. Cross multiply, we get 8 and 7. 8 is greater than 7, so 4/7 is greater than 1/2. So 4 pi over 7 is greater than pi over 2. That is going to exist within quadrant 2. Quadrant 2 is not part of the angle restriction for the tangent, so we are going to want to chase this from quadrant 2 into quadrant 4. We know this angle. We're looking for this angle. Now, the quick answer would be if I start here and simply subtract half of a rotation, that'll take me from quadrant 2 down into quadrant 4. Now, if we wanted to label this point, this would be negative x and positive y, meaning that the tangent of this angle would be negative y over x. The fact that it's negative indicates that I would want an angle in quadrant 4. So if we take our 4 pi over 7 and subtract pi, we will get the desired angle. Getting a common denominator, multiplying by 7 over 7, we'll get negative 3 pi over 7.